Good afternoon, my dear friends. Welcome back to my YouTube channel, Coding with Vinod. Today, I am going to solve a lead code problem on March 21st. The problem is find all possible recipes for a from given supplies. That means we have to find out what are the ingredients that are required for a preparing of recipe. Don't think you are going to prepare a recipe. It is just a question. Let's see the problem statement. You have information about n different recipes. You are given a string array recipes and a 2D array of ingredients. That means, suppose if you are preparing bread, you need chapati flour, that is maida, and water. Let's suppose, and water. These are the, for a recipe, we are given an ingredients in 2D array. In 2D array. That means each element represents the recipe's ingredients. Now, the ith recipe of the name recipe of I, you can create it with the needed ingredients from the ingredients of I. I have already said that for preparing a recipe, you require the following ingredients that are represented in ingredients of I. A recipe can also be an ingredient for other recipes. Same for preparing of bread, the flour. For preparing of chapati also, we require flour. That is, it can have two or more same ingredients. You are also given a string array supplies containing all the ingredients that you initially have and have an infinite supply. One supplier, there is a supplier who supplies the different types of ingredients, that are required to prepare a recipe. This is the recipe. Return a list of recipes that you can create. You may return the answer in any order. Note that two recipes may contain each other in the ingredients. Now I think the problem statement is clear, but somewhat we haven't got the idea about this problem. Now let us see how I got the idea about this is for preparing of, let's see an example. For preparing of bread, we require yeast and flour. For preparing of bread, we require yeast or yeast and flour. These are the two requirements. That means this is, if we have in these elements, then we can prepare bread complete. Here, this recipe is depending on the yeast and flour. Here, somewhat dependency. We see that the keyword called dependency, and it is making a tree structure of nodes. Somewhere it is getting an idea of topological sort. Topological sort. It is a concept in graphs. You can go through this. Let me explain this briefly. What is topological sort? It is going to very long video. Please understand, my dear friends, what is topological sort and how this problem is solved using topological sort. Topological sort is topological sort. When to use topological sort? When to use topological sort is one, when it is a directed acyclic graph. That means it should be directed and it should contain acyclic nature. That is, cycle should not be contained in that condition. And when you have to find dependency, that is, U is depending on V. That means for completion of the work of V, for completion of work of V, for completion of work of U, it is depending on work V. Let us take an example. Let's take an example. How this dependencies. For preparing of gulab jamun, let's take an example of preparing of gulab jamun. Preparing of gulab jamun. First, we should take flour of gulab jamun powder. We should mix it with water. We should mix it with water and make balls. Roast the balls. Roast the balls. Roast the balls. Roast balls. Prepare sugar syrup. Prepare sugar syrup. Prepare sugar syrup. But after preparing sugar syrup, we dip it into this. That means, depending first for the third step, we should complete these two steps. For the fourth step, we should complete these all steps. That means there is containing a dependency. When there is dependency, that means before completion of work we cannot complete work U. So for preparing of recipes, we calculate the ingredients. We calculate the availability of ingredients for these supplies. Now, how to solve this topological sort? There will be, suppose this is a graph 3, 4, 5, 6. I am explaining, my dear friends, what is topological sort. Now, it is not a sorting algorithm. It is not a sorting algorithm, but it is used to find out if one thing is depending on the other thing. To solve the problem, we use this topological sort to, like, similar to BFS and DFS. BFS and DFS. That is, we are finding the, for traversing of the graph, how you use BFS and DFS. In the similar way, we use topological sort. Topological sort. It gives the linear order of the vertices in the directory. It gives the, these are the, what I am speaking that are important, my dear friends. Please note down the points. That is, topological sort is a, when is used to find out the linear order. It is used to find out the linear order. We can solve this topological sort using two algorithms. That is BFS and GFS. BFS and DFS. I think all of you know that this is breadth first search and BFS is depth first search. The algorithm which is used to solve the topological sort using DFS is called Khan's algorithm. Khan's algorithm. This is important. Khan's algorithm. Let me explain what is Khan's algorithm. Now we solve this using DFS, using which is called as Khan's algorithm. Or which is called as Khan's algorithm. How this is solved is, we maintain, for what is DFS? It is depth first search. Depth first search. Depth first search, in which we go through the neighboring vertices. Through neighbor vertices. Through neighbor vertices, we go on searching for the, we go on search for the other elements using the neighboring vertices. This is DFS. Now, DFS, let's, what is DFS? Somebody will be getting doubt that what is DFS. Now, instead of going level by level order, that is BFS. BFS is also called as level order traversal. Instead of going level order, we go through the, if we take one vertex, we go through the depth of this vertex. After iterating, we come back and we iterate through this. This is called DFS. This is called DFS. That is depth first search traversal. That is depth first search traversal. I think all of you have got what is DFS and what is BFS. Now, how this Khan's algorithm will be solved is, first we keep track of the queue data structure. Queue data structure. For every element, we iterate through the 0 to n. There will be given n elements. Let us take an example. This is an example. This is an example. Here it is starting from 0. Suppose it's starting from 1. It is starting from 1. Generally, it will be starting from 0. Let us see by keeping it as 1 and solve the problem. I am discussing about the topological sort only, my dear friends, not the problem statement. This is the one of the part of the problems today's problem statement. That is, we are tracing from 1 to n. We keep add we keep the elements into the hash map in the queue. In the queue, let's suppose queue be queue. First, we go through the first element. Let's see whether it has any adjacent elements. It has adjacent elements 2 and 4. We keep 2 and 4, 2 and 4 also. And we keep track of the integrity elements. Integrity. What is integrity? I will explain what is integrity also. Suppose we are taking from 1, 2, 3, 4, 5. My charging is down. Let me plug in my charge. So it is clear. What is integrity? Integrity is used to solve. Suppose in a graph there are like this vertices. Integrity is the number of nodes that are coming to this vertex. Nodes coming to this vertex. Coming to this vertex. To this vertex. It's called integrity. What is out degree? Number of nodes that are going out of this vertex. This is in degree and this is out degree. Let's see what is in degree and out degree of this. In degree of 1, it is represented as in degree of 1 is equal to, what is in degree of 1? That is number of nodes coming to this vertex. Any nodes that are coming to this vertex, like this, no nodes are there. That is coming to this vertex. That is in degree of 1 is 0. And in degree of 2 is, here you will get what is the in degree of idea. In degree concept will be cleared here. That is, 2 vertices are coming to this element. That is, in degree of 2 is equal to 2. Let's see what is in degree of 3. What is in degree of 3? The in degree of 3, number of elements that are coming to 3 are 0. 0. Let us see what is the out degree. Out degree of 1 is equal to the number of nodes that are going out of this vertex. That are going out of this one vertex of number of nodes. That is only one node. That is only one node. The out degree of 2 is equal to number of node vertices. Nodes are going out of this vertex are 0. That are only 2 in degrees are possible. That is 0. Out degree of 3 is equal to number of nodes that are going out of this vertex is 1. That is 1. And similarly, initially we calculate the number of in degrees for it is the in degree array. It is in degree array. We can keep track of array or hash map. We can keep track of array or hash maps. Array or hash map. Here we are using array. Let's see in the problem statement how it will be solved. Suppose the example is 1, 2, 3, 4, 5. Topological sort is possible only when it is direct acyclic graph. It is not forming cycle. So it is directed not a cyclic graph. So it is acyclic. We calculate the integers of each element. For 1, the integer of this element is 0. For 2, integer of this is 2. For 3, integer is only 1. For 4, in degree is only 1. For 5, the in degree is 1. Calculate the total number of in degrees, and this will be equal to the number of nodes of this graph. Please listen, my dear friends. It is going to be more interesting now. How this will be sorted? We can, if there is dependency, if here we can see that dependency for calculating of the order, we should calculate the first. We should calculate the twoth value. So here, what we do when in degree of any element is 0, we keep that in an answer array. If suppose here when in degree of any element is 0, then we keep track of it will be the answer. It will be the sorting answer. It is now we go on track of this in degree array. Here we can see that it is one node, one vertex has 0 in degree value. So we keep on we add on the answer. Now we took this and pull out of the pole. That means FIFO follows the FIFO order. First in, first out. We remove the element and we keep track of the adjacent elements. What are the adjacent elements? These two are the adjacent elements. We check for these adjacent elements. We remove the in degree of these elements. We remove the in degree of this element. That means we have came to this element. Mark it as I have came to your home. So we can mark it. If suppose in the summer holidays we are planning for a trip. If two, we have to keep track for every element. When we have entered this home, we go on removing the element. These are the adjacent elements. And when the in degree is 0, we keep track of that house will be marked as 4. That house will be marked as it is completed, that is tracked or visited. Here in DFS we use visited array. Visited array. Here we doesn't need an visited array because we are decrementing the value. We are decrementing the value. We are decrementing the value. Once we see that decrementing the value, once we are visited value, when we are visited. If we are visited, then we decrement the value. We decrement the value. This is using DFS. Let us see if we solve this similarly. If we solve for every adjacent element, we decrement the in degree value. If any in degree value is 0, we keep those element in the answer array. This is the problem. Here also similarly, if we take the ingredient, for an, if we take an ingredient for recipe, the ingredient value will be decreased by -1. So we should keep track of these elements. It will be nodes. Ingredients will be getting -1. That is, we keep track of the nodes as in the in degree array. These are the recipes. Now the recipe, for preparing of recipe, we should first calculate the ingredients that are available or not. This means it is depending. The topological sort may be applicable for this. This is the topological sort order which I have discussed in this example. The same thing is given in the code. Here you can see initially we keep a query queue. For every supplies, we add all the elements, ingredients or supplies element to this. What are the supply elements that are available for this ingredient? We keep track of in the queue, and we keep the list array, that is answer array. If that particular index that are in degree of the particular index double equal to 0, we remove we add those elements to the answer again. Now, for keeping track of this, for here we have initialized using in degree array. Now we should keep track of these elements in the hash map because they have said in the range of string and integer. So the better approach to solve this is using hash map. Better approach not, it is the one of the solution to find the problem. We can solve using hash maps. We keep track of the every element that should be inserted into the hash map. If that element is present, already present, we increment the recipe value with 1. With 1, and after it will be, this is the initialization step. This is the initialization step. That means initializing the in-degree array. Similar what I have discussed, if you go through this, if you once understand this code, then it will be easily solved. It is a generalized code for topological sort. Now, where can this topological sort can be used? This topological sort is used when there is a deadlock situation. There is allocation of the when the allocation of space in the in memory, in memory. So this deadlock can be useful. This is the application of the topological sort. Here, my dear friends, I have clearly explained what is the intuition for this problem and how we can came through this dependencies. And for dependency solving, we use a topological sort. This topological sort, how this topological sort is clearly I have explained, and I have explained the code for this problem statement, and I have explained about the applications. This is the problem statement and the problem, my dear friends. Thank you, my dear friends. Please subscribe to my YouTube channel and share with your friends.